So it's going to be x to the negative 12 times x to the 5th. And then when you have the same base in multiplication, what do you do with the powers? Add them. Negative 12 plus 5 is going to be x to the correct. All done. If there's no negative, what do you do? One more thing. 1 over? Yep. There it is. The rule is, first one is a to the m to the n, that equals a to the mn. And then the other rule is a to the m times a to the n. What do you do? A to the m plus n. Those are the two rules that we applied. Those are the two rules. So to get from, so the 3 and the negative 4 right there, that's this rule right here.
Yeah, I know, but I'm saying, like, how do you know that? Because you have, like, x to the negative 12, like,
yeah.
Why is it you have to add that?
Because of this rule right here. Look what it says. You have the same base. You have x and x. So what do you do with the powers if you're multiplying? The rule tells you. We did this before. 2 to the 3rd times 2 to the 5th. What does 2 to the 3rd mean? 2 times 2 times 2. And what's 2 to the 5th mean? How many times? 5 times. So then how many do I have? How many 2's do I have right there? 8 of them. So it does equal 2 to the 8th. So how do you get 2 to the 8th? You add the 3 and the 5. So up here, it's the same exact thing. You have x to the negative 12 and x to the 5th. What do you do with the powers? You add them. Yes, if you do that, yeah, you can do that. So x to the 5th over x to the 12th. So that's 1 over x to the 7th. It's the same exact thing. It's the same exact answer. Yes, correct. The 5 x's on the top cancel with 5 on the bottom, leaving you with 7 on the bottom. So it's 1 over x to the 7th. Absolutely. 117 is 3k to the negative 2 over k to the 4th times 2 over k. So what would this first step here be? Well, oh, to the negative 1, sorry. Thank you. I got it. What should I do first? Distribute to negative. So it's going to be 3 to the k to the over k to the times 2 over. Now what should I do? Tell me what I should do next.
Minus the k and the k's.
Yeah, so it's going to be 3 to the negative 1 times what? K squared minus what? 2 minus? Is that what you mean?
Yeah.
Okay, let's actually, before we do that, let's simplify the denominator first. Simplify the denominator. We have k to the negative 4 and k to the 1. What does that become?
K to the negative 1.
Yeah, so you have 2 times 3 to the negative 1 times k squared all over k to the negative what?
4.
Nope. What do you do with powers? What is k to the negative 4 times k to the first? It's k to the negative 4 plus 1. K to the negative 4 plus 1. So what becomes negative what? 3. I'm just simplifying the numerator and denominator first. Now, what lines up? You have that. So you have 2 times 3 to the negative 1 times k2 minus what?
3.
Nope, not minus 3. Minus negative 3. So what does this become? 2 times 3 to the negative 1 times k to the what power? 5th. We're almost done. We're almost done. What's left? Yes, so this is going to be 2k to the 5th over 3. And then you're done.
I have a question.
Rule is, Harrison, because that's a good question. Because the rule is a to the m over a to the n. What does that equal? Yes, over 1. It's over 1. It's not 1 over that, it's over 1. That's the rule.
So it's 2k to the 5th.
What is 3 to the negative 1?
It's 1 over
1 over 3. No, it's 1 over 3 to the first power.
Yeah.
So therefore, what does that become? 2k to the 5th all over 3. That's where it comes from.
Oh, yeah.
Do this.
Distribute that negative 3.
So it's 5 to the negative what?
Negative 9.
Negative, no, it's 5 to the negative 3.
Oh, 5 to
What's the power of 5 right there? 1 and 1 and 1 and 1, right? All those are to the first power. So it's 5 to the what?
negative 3.
Z to the?
Negative 9.
Yes. Over 2 to the?
Negative 3.
A to the?
Negative 6.
Yes. Times 8 to the? A to the? Yeah, to the third. Yeah, not negative 3. Good catch. Over 15 to the? Z to the Yes. So we've distributed the power. That's all we did there. So what are the numeric coefficients that are left on top? There's 5 to the negative 3 and what else?
Z to the negative 9.
8 to the numeric numbers.
Oh.
And then Z to the... And do I like to put Z first? No, I like A first. Why? Alphabetical order, yeah. And then what does the bottom become? 2 to the negative 3, 15 to the negative 3. Is there anything that can be combined? A to the negative 6 and Z to the... It's just a lot easier to line things up now. Now what can I do? Now what can I do? Correct. So what can I do to simplify this? Do you have any common bases on the top and bottom? So what do you do to the powers when you have a common base? You subtract. So your first fraction, let's just leave this alone for now. I'm going to leave all the numbers by themselves. Is that okay? I'm going to leave all those by themselves. But then it's multiplied a to the what? 3 minus negative 6. Z to the negative 9 minus what? 6. So what do those... This is going to stay the same. I'm not going to work on that one yet. What's 3 minus negative 6? 9. And what's negative 9 minus 6? Negative 15. I'm going to have the same thing right here. So what does this become? A to the 9th over what? Z to the 15th. Yeah, it'd be a to the 9th over 1 times 1 over Z to the 15th. So I'm just going to combine them. But, I'll write that out. So that's a, yes, that's a to the 9th over 1 times Z, 1 over what? Yes, Z to the 15th. So this becomes that number, whatever it is, times a to the 9th over Z to the 15th. You see how I didn't try to do too many things at once? Break it down into small, easily digestible steps. Break it down into small, easily digestible steps. Now, though, what do we have to work with? This thing. So theoretically, well, let's see what we can do without going totally crazy. If you find yourself multiplying out some huge exponent, ask yourself very clearly, do I absolutely need to multiply this out? So we're going to try to simplify this before we multiply it out, and this is along for the ride. First of all, negative exponents, we don't like those, right? So what does the top become? 1 over 5 to the times 1 over all over 1 over times 1 over. Exactly. We can do a lot of... Hold on, kids. If we played the could you game with these, we will never get through any of them, okay? So we're going to do it this way, and then you can suggest faster ways to do it, okay? We need to do it out step by step because there are certain things you're going to skip. Like when you do these in the future, you're not going to write that out right there. There's a much quicker way to do it. That's fine. But we need to see why it's the case now. What do you do when you're dividing by a fraction? That means you can multiply by the... So what does this left side become? It just becomes 2 to the third, 15 to the third over 5 to the third, 8 to the third. And what's left over here? What? A to the 9th over Z to the... It's just along for the ride. Now, do you think that can be simplified a little bit? Yeah, and there's actually a really cool thing you can do to simplify this. I'm going to give you a quicker way. We knew this, right? We had this rule, A to the M over A... Sorry, we knew this. A over B to the M, what does that equal? A to the M over... This is also reversible. You can go either direction. So if you had A to the M over B to the M, you can go backwards and make it A over B to the M. What do you notice about all of the powers in this one right here? They're all what? So what can you kind of like pull out? The 3. So what does it become on the inside? 2 times 15 over 5 times 2 the... Now, is that a lot easier to work with? Yeah, because what's 2 times 15? You can do this. That cross that out, that becomes a 4, right? That and that, what does the top become? 3. 5. 15 divided by 5 is what? 3. So it's what? 3 over 4 to the third, A to the 9th over Z to the 15th. You could stop there, and there's nothing you would be forced to do next. That would be super simplified. Another way to see 3/4, it would be 30 over 40. What's 2 times 15? 30. 5 times 8 is 40. 30 over 40. So you could multiply it out and then simplify. I like crossing the common factors out. But you end up with, is there anything else we could do to that? You could multiply. What's 3 to the third?
27.
So I would imagine the book is going to write 27 A to the 9th over, what's 4 to the third? Do you remember? Yeah, 64 z to the 15th.
That would be perfectly correct.
Totally fine, either one. And here's the thing: is it totally clear which one is most simplified?
Yeah.
Really? Which one's most simplified? Why? So what? Those are smaller numbers. It depends on how you define most simplified. Like we've gotten rid of all the exponents, right? That's fine. But for me, I'd much rather write 4 to the third than 64. 4 to the third power is much more useful to me. Then again, either one is fine. The only reason you'd want to choose is time is your most valuable asset on most tests. So sometimes don't spend, you need to know when you're done. And yes, it's hard to see that. Connor asked about it. Like, when are you done? You're done. Either one right there. There's lots of different ways you can be done. Are there other paths we could have taken on this one? Yes, absolutely. Yeah, so what is that going to become? 8.75 times?
10 to the first or second?
Is that bigger or smaller than what you started with?
I mean, it's, I meant to the negative first.
You're done. All done.
But the only thing is, isn't anything to the first just itself?
10 to the negative 1 is 1 over 10. 10
Wait,
to the first does not equal 10 to the negative 1.
No, but I'm saying like 10 to the first doesn't that just equal 10?
Yes.
So then why would, like...
Why would what?
If you had, let's say it was 87 points.
And there's a lot of notation in 5.3, but it really breaks down to this. It really breaks down to a pretty standard idea, some of which we've seen before, which is the following. Let's say I said f of x is equal to 2x squared plus x minus 4. What can you tell me about what I've just written on the board? What could you tell me about that function? Tell me one specific thing about that function. One specific thing. Shane. What is it? What kind of function is it? Yay, it's a trinomial, which is a type of what? Polynomial. We did talk, we had that word on, right? Polynomial? Okay, good. It's a trinomial, nice. What's its name? The function's name? Nope, close. Nope. F. The name is F. The name is F. It is the function f. You could call it Bob if you wanted to. It could be Bob of x. If you wanted to call it Bob, it would be Bob of x is equal to that. You can call it anything you want. Okay. So what does this mean? If I said this, what does that mean? Plug in what? Plug in x? Plug in 2 for x. Correct. Plug in 2 for x. So if you did that, it would be 2 times x squared plus x minus 4. But instead of x, what do I write? 2. What's 2 squared? So that would be 2 times 4 plus 2 minus 4. So what would that be? 8 plus 2 minus 4 is? 6. The whole thing is. But 10 then 6. Yes. Nice. So you're just plugging in 2 for that. We've done something kind of like that before. What about if I asked you like f of a? What would that be?
Substitute the f.
A in 4. So what would it become?
2a squared
Plus.
a minus 4.
So whatever you plug in there is just going to get substituted in for x. That's it. What happens if I said this? Let's say f of x was equal to 2x cubed plus 7 and g of x was equal to 5x minus 2. Let's say I asked you for f of x plus g of x. What does that mean? What does that mean? Add them together. That's it. You're just adding the two things together. Can someone tell me what that is going to equal? Liv.
2x squared.
2x cubed.
Sorry.
Yep.
Plus 5x plus 5.
Plus 5. Why is it plus 5?
Because you have to combine the
2 and the negative, the negative 2 and the 7 combined to be 5. Excellent. And it's written in descending order of powers. 3, then 1, then 0. Right there. X to the 0. That's nice. This right here can also be written as f plus g of x. It's the same thing. They mean the same thing. It's just slightly fewer pen strokes, and mathematicians like to summarize. Mathematicians love to summarize. So what does this mean? Let's say I had j of x is equal to 2x squared plus 5. N of x is equal to 7x plus 2. What does this mean? What does that mean?
You're just
2x.
Not what it is. What does it mean? You're just subtracting. Yeah, you're just subtracting what from what?
The first
Two
J of
x squared plus 5 minus
J from n. Yes.
J.
J from n. So what is that going to be? 7x plus 2 minus what?
2x.
Squared plus 5. And what does that simplify to? Someone who hasn't said anything. Anybody want to volunteer? What does that equal? Someone who hasn't spoken up today. Zoya, what does that equal? Minus what? Squared minus. Is that written in the proper order? No. What order is proper, Nick?
Negative 2x squared.
Yep. Plus.
2x
Close. It's just 7.
plus 7.
Minus what? Minus.
Negative 3.
Minus 3. Yes. Minus 3. Exactly. So are those written in? Is that the proper order? So a bunch of this section is just notation. A bunch of this is just notation. So if I ask you for f of a, can you tell me what that is, Zoya?
3a squared.
Correct. Nice. You just plug it in. Yep. To the correct. So it doesn't matter what I plug in there. You just put it in. So what does this mean, Harry? F of g of x. What does that mean? What are you plugging into what? What is f? 3 times what? X squared plus 7. But instead of x, you're writing g of x. What is g of x? So it's going to be 3 times negative 7x to the 5th squared plus 7. This is called function composition. You're taking one function and plugging it into a. This is just substitution. This is just substitution. Notationally, this is also written. This is the same way of writing it. This. You see that little open circle? These are the same. They mean the same thing. This means you're plugging G in for F. It's kind of annoying because a circle looks like a dot. What do you think a dot is? Multiplication. Open circle does not mean multiplication. I'm telling you this now because the book likes to use this. Either one of them is the same. This is just a few less like pen strokes. It means the same thing. So what would this mean? What does this mean? G of f of x. G of f of x. What does that mean? Plug what into what? You're plugging in f into, so it's g of f of x, like that. You're plugging one into the other. So if we had the same functions, so let's say we took these same functions right here, are we going to get the same answer we had before? No, we're not. Function composition doesn't give you the same thing in both directions. So if I did that, what is g? G is, so g of f of x is going to equal negative 7. Instead of x, what are we writing? F of x, yep. And what is f of x? I'm just doing one intermediary step. No, don't apologize. 3x squared plus 7 to the... Is that the same as what we got before? No, take a look. We got this before, and then we got this. Are these the same? Not the same. Okay, as a fun, another one, what's this going to be? Well, what does this mean? F O F X. What does that mean? Yes. You're plugging f into. Can you do that? Absolutely. What is f of x? What is it? So f of x is going to be, what is f? Oh, it's 3 times x squared plus 7. But what do you plug in for this? Right there. Could you do g of x? Absolutely. Absolutely. This is just substitution. This is just substitution. Do that first. Just ignore this right now. Ignore that. Find me f of g of x. Do that right now. Into what? What are you plugging into what here? You're plugging which function into f? So you're plugging g in. What is f? It's x squared. So instead of that, you're plugging in g. And what is g? So it's going to be x plus 3 squared. So what happens if I ask you, what's f of g of 4? What does that mean? 4 plus 3 is 7 squared, which is what? 49. Exactly. Exactly. Okay.